Today, we're adding persistence to our graph. This will provide long-term memory and the ability to load previous conversations. Let's continue from where we left off. At the end of tutorial 2, we built a script using a custom reducer, keeping a series of Fibonacci numbers. This is the script as we wrapped the last video. And just to be sure, let's give it a run to see if everything still works. Okay, the script runs and we have our Fibonacci series recorded into the graph state. That's good. Let's inspect the graph image, and yes, it is the same as last time. Great. Now, to add persistence to our state, we're going to make a few changes. First, let's update our script description. We'll persist the state of the graph using SQLite as long-term memory. We'll utilize the SQLite saver class from the LangGraph checkpoint SQLite module to save the state of the graph to a local SQLite database. First, let's add our imports. We'll use SQLite 3 and SQLite saver from LangGraph.checkpoint package. Next, we're going to create a connection to SQLite, passing it a database name. We will also replace our checkpoint or memory object type from memory saver to SQLite saver. These are really the only two changes needed to enable state persistence with SQLite. Before we run the script, let's install a useful extension that will help us view and query SQLite databases without having to leave VS Code. Navigate to your extensions pane and in your search box, type SQLite. Grab the first result with the 2.9 million downloads. Click install and wait for the download to complete. Once installed, let's go and run our script. Navigate to your terminal and type python state.py. Immediately, you'll notice that 3 new files that were created in the project folder on the left. These are the SQLite database files. The LangGraph state will be persisted to these files every time there's a change to the state. When this happens, LangGraph will append a new checkpoint and write the state into the file system. Now let's quit the app, clear the console, and then run it one more time. And this time, the graph state will be initialized with the contents of the latest checkpoint saved in SQLite. We will see an array consisting of 0, 1, 2, 3, and 5. This is really important, as it demonstrates a successful database read operation and proves our state is now persisted and loaded successfully. Next, let's inspect the SQLite database and see the contents of the tables. In Visual Studio Code, hit Shift-Command-P and then SQLite Open Database. From the list of files, select the one in your project folder. Immediately, the database will be loaded and displayed in the SQLite Explorer pane on the bottom left. Let us explore the checkpoints.sqlite database by clicking on it and verifying the 2 new tables, checkpoints and writes. Right-click on the checkpoints table and select Show Table. You can close the other editors to give SQLite more space. Feel free to explore the checkpoints table and confirm the number of columns added, such as thread ID, checkpoint, and metadata. Inspect the metadata column by navigating to the last row and confirming that is identical to the last Fibonacci series executed from the graph. Now let's run a select query against this table. Navigate to the SQLite Explorer, right-click on the table and select New Query Select. In the new pane, you'll see the select query already populated for the table. Let's limit it to thread ID and metadata. Right-click and select Run Query. Go back to the table and inspect the query results. You can also delete all rows in the database if you'd like to reset the state. Right-click, select New Query, and write Delete Query. I'll ask Copilot for a little help, and once the suggestion is in place, I'll just replace the table name. Once done, right-click and select Run Query. Back in the table editor, all rows should now be gone. Let's open state.py and run it one more time. And now the sequence starts from 0. That's because we deleted the previously saved state and now the graph is empty. If we now run another select star query, we will now see the new rows populated back to SQLite. Write the query, run it, and inspect the table. Now let's run another experiment. Let's go back to state.py and change the thread ID to 2. Let's save and run our script. Because there are no previous runs with this ID, the state will start blank. If we rerun the select star query and inspect the table, we will now see both IDs displayed in the results. If more items are added to the Fibonacci list, the state will continue to be persisted and the query results will reflect updates. You can go back to the select query and limit by thread ID. When you run this query, it will limit the results to those with the specified ID. This is one of the ways to filter results when you want to return content for a specific thread or user. Changing the thread ID to 2 will only return those rows with ID of 2. To summarize, we have successfully created a LangGraph state graph, taking SQLite as a checkpointer and persisting itself to the file system. The important part here is how we are creating the connection to the SQLite database. LangGraph is persisting and loading the graph state automatically, and we don't need to do anything special for this to work. That's it for this part. I hope this was helpful and it was a good investment of your time. If you like content like this, please remember to like, share, and subscribe to this channel for future updates. It helps with the YouTube algorithm, and it helps us create a better and larger community of AI developers. Thank you for your time today, and please let me know if you have any feedback or any requests for videos in the comment section.